Hello friends, and welcome to edupediaworld.com, your favorite portal for online education. Continuing with the previous session, where I had posted an assignment for you to solve on Spearman's rank correlation. I hope you must have solved and got the answer for it, but let me give you the solution for that in this session. Let's recall the question. The question was about 3 judges judging 10 competitors, and the ranks given by the 3 judges X, Y and Z are given in this table. You need to find the Spearman's rank correlation for each pair of judges, that is for X and Y, Y and Z, and then X and Z. And then you need to interpret the answer. Further, you need to tell which pair of judges have the nearest approach to common taste. And also, you need to check whether the Karl Pearson's coefficient of correlation are the same as that of Spearman's rank correlation, or are they different. So let's take the questions one by one and solve them. To start with, let me first solve this and find the row values for X and Y, Y and Z, and X and Z. So here we have 3 judges. Let me first find the difference, that is D, between X and Y. So let me write that as dxy. And that will be the value of X minus the value of Y. Okay, we need to square this. Let me do that here. dxy raised to power 2, and that will be this value raised to power 2. Then I need to find the value of D, say X and Z, and further square that also. And finally D, Y and Z, and the square of that. Okay, so D, X and Z will be equal to the value of X minus the value of Z, and DYZ will be equal to the value of Y minus the rank given by judge Z. And then squaring them here. Let me drag this down for all the rows, and here we have the values of the square of the deviations between X and Y, Y and Z, and X and Z. Next, I need to take the sum of all of these. The sum, of course, when you take the sum here, this is going to be 0, but we need the sum only for the squares, and here we have the values. Okay, I don't need this, this and this. So I have the squares, sum of the squares as 200 for X and Y, sum of the square for X and Z is 60, and sum of the square for Y and Z is 214. Okay, so I have the sums here. Let me just make it bold. Next, I can use the formula. I have a numerator and a denominator. Let me do that step by step. In the numerator, for X and Y, the value would be 6 times the value here, right? That is 6 times summation dxy square. Similarly, for these two, the value will be 6 times the corresponding value of the sum of the square of the d, that is the deviation. Okay, in the denominator I have n multiplied by n square minus 1. My n is 10, so it will be n times n square, which is the square of 10 minus 1. Yeah, so that's 990, and since the value of n is same for all the three, the value would be the same. Okay, and then finally the value of rho, that is the Spearman's rank correlation for x and y, would be 1 minus the numerator, that is 6 times summation di square divided by n into n square minus 1, that is the denominator here. Okay, so when we do that, the value we obtained is minus 0.212. okay, that's the value for the Spearman's rank correlation between x and y. In the same way, the value for y and z and x and z are given here. Okay, so let me just mark them with a different color. So the value of rho for xy, xz and yz are given here. Okay, so we've got the values. Now we see that the correlation between x and y is negative. Similarly, for y and z are also negative, which indicates that the taste of the judges x and y and z are not the same, they are the opposite. Although the value is low, it's not very highly negatively correlated, it's lowly negatively correlated. Whereas for x and z, the taste are the same, because here the correlation values are positive, not very high but moderately positive linear correlation. Okay, well, now going to the Karl Pearson's coefficient of correlation between these three, because if you recall, the third part of the question says that if you asks whether the value of the Karl Pearson's coefficient of correlation would be the same as that of the correlation between ranks, or would they be different. So let's check it out, because we have already done the Karl Pearson's coefficient of correlation several times. I hope it shouldn't take much time. So let's do them one by one. First between x and y, then we shall do it between y and z, and then finally between x and z, and see whether the values which we have got using the Spearman's rank correlation are the same or not. So let's do here between x and y. Let me remove this one, because we just have x and y in this case. So here first I need to take the product of x and y, then I need to find the square of x, and finally I need to find the value of square of y. Okay, so this would be the value here multiplied by y. This would be the square of the values of x, and this would be the square of the values of y. Okay, now dragging them down for all the cells here, I have the values. Then I need to find the sum very quickly. The value of sum, I need the sum of x and y as well, so sum of x, and we know that the sum of x, sum of y and sum of z will all be the same, because the ranks are the same. Okay, so here we have, and then the sum of x, y, x square and y square are the same, and since the sum of x and y are the same, we have the same numbers, the sum of x square and y square will always be the same in all the three cases. Okay, in the case of x, y as well as z. Next, what is the formula to find the correlation coefficient, that is the Karl Pearson's correlation coefficient? It's n multiplied by summation xy minus summation x into summation y divided by square root of n into summation x square minus summation x the whole square, and then the square root of n into summation y square minus summation y the whole square. So let's do it in parts. First the numerator, and then we shall take the denominator, and denominator we shall take in two parts, one for x and one for y. Okay, so numerator here, the formula is n, which is 10, n multiplied by summation xy, which is this, okay, minus summation x into summation y, this value into summation y, which is here. Okay, next the denominator, it's square root of n, which is 10, multiplied by summation x square minus summation x the whole square. Summation x is this, raised to power 2. Okay, similarly the denominator for y would be square root of n multiplied by summation y square minus summation y raised to power 2. Okay, and finally the value of Karl Pearson's coefficient of correlation will be the numerator, that is this value, divided by the products of both the denominators. And here we have 0.212, a negative value, and that is exactly what we have here. Great, so we see that the value is the same in case of x and y. Let's see if it is the same with y and z and x and z. So here let's do x and z. Let's remove y from here, multiply x and z, then find the square of x and find the square of z. This is the product of these two numbers. Here this would be the value of x raised to 2, and this would be the value of z raised to 2. Okay, then let me drag it down to all the cells here, and then take the sum of this. Yeah, I have the sums. Then I need the numerator and the denominator for, in this case we have x, and the denominator for z. Okay, so very quickly the numerator here would be 10 multiplied by summation of x multiplied by z minus summation x into summation z. Okay, and the denominator will be, for x will be square root of n multiplied by summation x the whole square minus summation x raised to power 2. And you see that the the denominator values are the same, because you see that whatever is inside the formula are all the same in case of x, y or z. The square root of n multiplied by summation z minus the square of z. Okay, and finally the value of correlation coefficient will be equal to the numerator divided by the product of the denominators. And here we have, voila, we have exactly the same answer as we had previously. So it's between x and z. Let's see, x and z exactly is 6363. Okay, and finally let's do for y and z. Y and z, we need y multiplied by z followed by the square of the term y and square of z. Okay, so this will be the product of these two terms, and this would be this raised to power 2, and lastly z would be the value of z raised to power 2. Okay, and then we need to take the sum of these, which is exactly the same. So let's take the sums here. Okay, I have the sums here now, and then as usual let's find the numerator first and then denominator of y and the denominator of z. Okay, so the numerator value is n, which is 10 multiplied by summation y into z minus summation y into summation z, and then denominator for y would be square root of n multiplied by summation y square minus summation y the whole square. Okay, and then denominator for z will again be square root of n multiplied by z square, summation z square minus summation z raised to power 2. Okay, and finally the value of correlation will be equal to the numerator divided by the product of the denominators. And here we have, voila, we have again the same answer. So now we see that we get the same answer whether we use Karl Pearson's coefficient of correlation or Spearman's rank correlation. But is that the case always? No, that's not exactly the case always. Let me summarize the answers here and see when we do not have it in that way. So the answers are: the obtained value of rho for the pairs xy, xz and yz are minus 0.212, 0.636 and minus 0.297 respectively. We see that the values of the rho of x, y and yz are negative and they are very low, while the value of x, z is positive and moderate, which is an indicator of some degree of common taste between the judges x and z. Okay, we note that the pair of judges x and z tend to have the common taste, since the correlation between the rankings of x and y and z are negative. Therefore judge y seems to have a different taste. And yes, the answer for the last question is that the Karl Pearson's coefficient of correlation between ranks according to the two characteristics will be equal to Spearman's rank correlation when ranks are not repeated. Yeah, so the exception is that when the ranks are repeated. When you have repeated ranks, then the both the values, that is the Karl-Pearson's coefficient of correlation and Spearman's rank correlation for the given ranks, will not be the same. In case if the ranks are repeated, we call that as the case of tied ranks, and that we shall take in the next session. Keep watching Edupedia World videos. Thank you.